Hello, today I will speak about how the internet works, a simple explanation. How many of you have checked your email, streamed music, or scrolled through social media this morning? Almost all of us, right? We use the internet constantly, relying on it for work, communication, and entertainment. But have you ever stopped to wonder what actually happens in that lightning fast split second between clicking a link and a web page appearing on your screen? The internet isn't just a luxury anymore. It's a critical part of modern life, as essential as electricity. Understanding how it functions helps us appreciate the sheer complexity of the technology we use daily, and can even help us make more informed decisions about our digital security and connectivity. My fascination with the underlying mechanics of our connected world, coupled with research into these core systems, has given me insight into the complex, yet elegant, mechanics behind the web. I'm excited to peel back the curtain to explain how the internet works by exploring its physical infrastructure, the universal protocol language for smooth communication, and the step-by-step journey of your data. First, we will explore the vast, tangible network of wires and connections. Second, we will discuss the essential rules or protocols that manage data transfer. Finally, we will trace the journey of a data packet from your device around the world and back again. To begin, let's kill the myth of the cloud. The internet isn't some magical ethereal place. It's a massive physical network of interconnected computers, routers, and cables that span the globe. Your home or office network connects to this global behemoth through an internet service provider, or short ISP. Think of your ISP like a local post office. It connects many individual users and networks to the global shipping infrastructure. These connections rely on tangible physical mediums, the copper wires in your walls, high-speed fiber optic cables under street, and wireless signals that carry data over long distances. It's all hardware. This global network is mind-boggling in a scale. It includes vast undersea fiber optic cables running along the ocean floor and massive, highly secure data centers that store all the information we access. The sheer scale of this infrastructure is what allows for a network of networks, which is the literal definition of the internet, so it can exist and function seamlessly. This global connectivity evolved from early military and academic networks like the ARPANET in the late 1960s, providing that decentralized communication could work even under extreme conditions. Now that we know the physical path exists, the next crucial question is, how do all these wildly different devices made by Apple, Microsoft, Google, etc. manage to communicate? The answer lies in a standardized communication language called protocols. The core of this linguistic system is the Internet Protocol Suite, universally known as TCP/IP. TCP stands for Transmission Control Protocol. It's a vital job to guarantee your data is delivered reliably, completely, and in the correct order. It's the reliable mail carrier. IP stands for Internet Protocol. This is responsible for addressing and routing, making sure the data knows exactly where to go. It's the address label. You can think of TCP/IP like a global postal system rules. The IP address is like the unique street system or zip code on an envelope. Every single device on the internet has one, acting as its unique identifier. The domain name system, or DNS, acts as the internet's phone book, translating human-readable names like google.com into those tricky numeric IP addresses, making the internet user-friendly. So, we have networks of connections and a set of rules. How does your information, like this speech, text, or a video file, actually travel? It's broken down into digital pieces called packets. When you send data packets, TCP breaks down the information into numerous small packets, each like a tiny envelope with the source and destination IP addresses written on it. This packet switching method is incredibly efficient because it prevents any one user from monopolizing the network and allows the data to take different optimum routes around the traffic jams or broken connections. The network routers use the IP address like a GPS, deciding the best path for each packet to travel across various networks until it reaches its final destination. Upon arrival at its destination, the process reverses to magically reassemble the data. The receiving computer's TCP layers collects all the packets, checks them for errors, requests any missing ones, and stitches them back together in the correct order to form the original message. All this happens incredibly fast. typically in a fraction of a second, which is why web pages load almost instantly and video streams smoothly. It's a true digital ballot. In conclusion, the internet is an engineering masterpiece that enables instant, seamless global communication. We've covered how vast physical infrastructure, governed by smart, standardized protocols like TCP/IP, works together to break down your data, route it across the world as packets, and reassemble it at its destination. From the robust and undersea cables that form the backbone to the traffic directing rules that manage data flow, every single click you make triggers this complex coordinated journey. It is this elegant system of connected networks and universal rules that make our modern digital world possible. The next time you instantly connect with someone across the world or country, take a moment to marvel at the invisible ballot of data packets making their incredible journey.